Hello, everyone. Welcome to today's lesson. Chemical production transforms raw materials into products, which requires a series of chemical and physical processing steps, and this series of processing steps is called the chemical production process. Next, we begin learning Scenario 6 of the Fundamentals of Modern Chemical Industry, Understanding Chemical Production Processes. Let's first look at a case study. In the contact process for producing sulfuric acid, it is necessary to first crush pyrite so as to increase its contact area with air, allowing the subsequent reaction to proceed more fully. Meanwhile, the air must also be purified to remove the impurities contained therein, so as to prevent them from affecting the reaction or damaging equipment, and this step is called raw material pretreatment. The pretreated raw materials then enter the reaction furnace, where a chemical reaction occurs, and the generated sulfur dioxide is further converted into sulfur trioxide after the reaction is completed. The resulting product contains various substances which necessitates product separation, and through a series of absorption, purification, and other operations, high-purity sulfuric acid is obtained. In this case, the production process of sulfuric acid is mainly divided into three basic stages: raw material pretreatment, chemical reaction, and product separation. First, chemical production process. 1. Composition of the chemical production process. There are thousands of chemical products in the world, but almost every chemical product's production process consists of three basic stages: pretreatment of raw and auxiliary materials, chemical reaction, and product separation. The manifestation of a chemical production process is a process flow composed of several unit operations and unit reactions connected in series. Through the three basic stages, raw chemical materials are transformed into chemical products. 2. Unit operations and unit reactions. Unit operations are basic processing steps characterized by physical changes, mainly divided into fluid flow processes, momentum transfer, heat transfer processes, energy transfer, and mass transfer processes. Mass transfer, fluid flow processes involve the movement of fluids and the relative motion between the fluids and the solids they contact. Common fluid flow processes include fluid transportation, filtration, mixing, and the fluidization of solids. Heat transfer processes involve the fundamental laws of heat transfer, and several unit operations governed by these laws. Common heat transfer processes include evaporation operations and heat exchange. For example, in a salt production plant, seawater is heated to cause the evaporation of water, leaving behind salt, thereby obtaining crude salt. In the chemical production process, high-temperature products after reaction can transfer heat via a heat exchanger to the raw materials entering the reaction vessel, preheating the raw materials while simultaneously cooling the products, thus achieving effective utilization of energy. Mass transfer processes involve the fundamental principles governing the migration of substances across phase boundaries, and several unit operations that are predominantly governed by these principles. Common mass transfer operations include gas absorption and liquid distillation when treating exhaust gases. A specific solution is used to absorb harmful gases from the exhaust. For example, sodium hydroxide solution is used to absorb sulfur dioxide from exhaust gases to reduce air pollution in the brewing process. Distillation can increase the concentration of alcohol by distilling the fermented wine. to obtain wines of different strains. Unit reactions are basic processing steps characterized by chemical changes, commonly including combination reactions, decomposition reactions, double displacement reactions, displacement reactions, and redox reactions. Next, let us study the knowledge related to process flows. Second, chemical production process flow. 1. Process flow. A process flow is the method and process by which various raw materials and semi-finished products are processed through specific equipment in a prescribed sequence to ultimately transform them into finished products. It demonstrates the flow and transformation of materials throughout the entire chemical production process, showing how materials move and change between various process steps and equipment, taking the production of plastic pellets as an example. First, petroleum or coal and other raw materials are pretreated to obtain suitable monomers. Then, through a polymerization reaction, the monomers are polymerized into polymers. Finally, after granulation and other subsequent processes, plastic pellets are produced. In this process, each step's conditions such as temperature, pressure, and reaction time must be strictly controlled so as to produce products that meet quality standards. 2. Process flow diagrams. Process flow diagrams are important tools for representing the chemical production process, mainly divided into process flow schematics, material flow diagrams, and piping and instrumentation diagrams, P&IDs, which use graphics, symbols, codes, and textual explanations to represent the flow of materials, the changes in materials, and the entire process of process control in chemical production facilities. Process flow schematics are divided into block diagrams and process flow charts. This is a process flow block diagram, which uses boxes and text to represent the process and equipment, and arrows to indicate the direction of material flow. This is a process flow chart, which is a diagram that, following the sequence of the process, displays the equipment and process flow lines from left to right on one plane to illustrate the process by which materials are transformed from raw materials into finished or semi-finished products. This is a material flow diagram, process flow diagram, abbreviated as PFD, which contains data or parameters regarding equipment characteristics, the names of components and flow rates before and after material changes, and the various totals. In this styrene crude distillation tower material flow diagram, we can see the composition and flow rates of the feed and the product, as well as information such as the equipment's heat load. In actual production, engineers can adjust production operations based on this data. This is a piping and instrumentation diagram, P&ID, which is also called a process flow diagram, with control points or a construction flow diagram. It includes all information on equipment, pipeline valves, and various instrument control points. In actual production, operators use this information to monitor and control the production process, ensuring safe and stable operation. Today, through our studies, we have learned that the chemical production process consists of three basic stages: raw material pretreatment, chemical reaction, and product separation, which is manifested as a process flow consisting of several unit operations and unit reactions connected in series. And process flow diagrams are important tools for representing the chemical production process. That concludes today's lesson. It is hoped that through this lesson, you will gain a deeper understanding of the chemical production process, laying a solid foundation for your future academic studies and career development.